From the moment I'm up, it's incredible. Yeah, feeling magical. Magical. It's about that time. I say what? Baby, rise and shine. I'm all about that, Yeah, I can feel it. It's about to be a good day. Yeah, I'ma kick it like I never had a bad day. Keep my chin up. That's all. Mama always said like, that's all.
What's up, everybody? I'm Crazy Aunt Lindsey, and you are in the Fab Lab. My Fab Lab professors today are Mari and Gabe, and today we're having a slumber party!
Crazy Aunt Lindsey, what does a slumber party have to do with science?
I'm so glad you asked, Mari. It's not so much about what happens at a slumber party, but when.
At night?
That's right, Gabe. And what comes out at night?
The stars.
That's right. Well, technically, stars are always out. It's just much easier to see them in the night sky. The evening is the perfect opportunity to introduce ourselves to all the things happening in our universe. Astronomy! Astronomy is the study of celestial objects. The sun, moon, stars, planets, black holes, and whatever the heck else is up there holding us all together in space, where everything is located. In this week's episode, we're stargazing and learning how to recognize clusters of them, constellations. We're gonna pop by the OMSI Kendall Planetarium and meet with an astronomer. We'll make FabLabulous constellation cupcakes to help us celebrate everything we learned. Then we'll make intergalactic popcorn and galaxy smoothies to round out our delicious slumber party spread. In the Fab Lab Active Hour, we'll do 2 sun salutations to say goodnight to the sun, moon, and stars. And lastly, we'll stop into the Fab Lab library, where we'll pick out my favorite book from childhood that got my imagination going about time, space, friends, family, and everything possible in the universe. A Wrinkle in Time. Stick with me for the Fab Lab Slumber Party, because science is fabulous. The Fab Lab with Crazy Aunt Lindsey, starring real kids from Portland, Oregon. Brought to you by OMSI. This beaker of popcorn, and a team almost entirely made up of neurodivergent creators. Because science is fabulous, and also for everyone. Science says that we learn best not just when we're having fun, but when we're relaxed. We're gonna take the Fab Lab heartbeat, a pause together to prepare our hearts and minds to learn about astronomy! The first thing we're going to do is a box breath. Some call it a square. We're going to inhale on a count of 4, exhale on a count of 4, and hold on each ends for a count of 4. Put our hands on our hearts, close our eyes, take a big breath in and out. We're gonna inhale on a count of 4. Go, 2, 3, 4, hold, 2, 3, 4, exhale. Hold. Did you know that the universe is always expanding? And every time I learn something new, my heart and my mind expands larger than it was before. I am the universe.
I'm ready to learn about astronomy.
Okay, to the lab. Astronomy is the study of celestial objects. The sun, moon, stars, planets, black holes, and whatever the heck else is up there holding us all together in space. For thousands of years, human beings have looked up at the stars, noticing patterns and telling ourselves stories about what it all means. This activity gave birth to something called astrology, the ancient study of movements and relative positions of celestial bodies, interpreted as having an influence on human affairs and the natural world. While most scientists turn their nose up at certain aspects of this kind of storytelling and oral history, astronomy as a scientific category owes a great deal of thanks to those first several thousands of years of early observers. Ever hear of Galileo? How about Leonardo da Vinci? Or those 3 guys that sent us to find Jesus? They were all astrologers. To this day, most of the constellations that we know about and their calculations are thanks to their ancient names and lore. Except now, we have more information and tools to help us understand exactly what's going on up there. For instance, we used to think that the sun was the largest star, but really it's just an average-sized star that's the closest to us, creating our solar system. A solar system is, in our case, the sun and everything that's stuck and revolving around it because of its gravity. Our solar system includes Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and little sibling planet Pluto. Come with me to OMSI, the Oregon Museum of Science and Industry, to meet my astrophysicist friend Alex, an OMSI educator, to learn more.
Welcome to the OMSI Planetarium, Lindsey.
Thank you so much, Alex. This is amazing.
Isn't it beautiful?
What can you tell me about this amazing place?
This is one of my favorite places at OMSI. This is OMSI's Kendall Planetarium. This is where we explore the universe and all of the amazing things that it has to offer.
This is all a screen.
Yep, everything around us is a screen. It's lit by projectors. We can use it to see what our night sky is going to look like tonight, tomorrow, next month.
So this is an amazing way to see stars that are far away, but up close. A star is a luminous little or big ball of gas, mostly made up of hydrogen and helium, all held together by gravity. Can you tell me more about stars, their shape, their life cycle? One thing in particular that I've been really curious about is their shape, because when I doodle in my notebook, I make like a cute little 5-pointed star, a 6-pointed star, but something tells me that's not actually what a star is shaped like.
Your instinct is correct. I have props. Okay, so stars are giant spheres of plasma, but stars are also spinning really fast. But what I want you to do is I'm gonna spin this star very quickly, and I want you to notice what happens to its shape.
Okay. Oh, it's flattening up like a little pancake.
That's exactly what stars are shaped like. The name is called an oblate spheroid.
Oblate spheroid. Say that 5 times fast.
And it basically is just kind of like a slightly squished sphere. Stars are spinning fast enough that they squish out a little bit into something flat.
That's so cool.
So when we look at stars, what we're looking at is the light that they sent us years ago. So the light we get from the sun is actually 8 minutes old, right?
That is mind-blowing. That is completely mind-blowing. Alrighty, we're back in the Fab Lab, and now it's time for Constellation Cupcakes. A constellation is a collection of stars that form a pattern, traditionally named after their form or mythological figure or character. Check out the Fab Lab Astro Pack on Patreon to download your very own copy of the Fab Lab Constellation Guide. It helps you learn to not just identify patterns, but hear about some of the stories associated with the luminaries in the night sky. All you need for this are some cupcakes, icing, decorations, skewers, and toothpicks. I'll show you why in just a moment. All right, guys, you ready to ice some cupcakes?
Yeah!
Let's do it! We made 12 chocolate and funfetti cupcakes and a bowl of Fab Lab sweet cream icing ahead of time to make this quick. The first thing you'll do is glob some icing onto your cooled cupcakes with a butter knife or spatula.
We're all gonna get eaten by the cupcake. Dun dun dun! I love how we said that at the same time.
Next, put them on a tray and get to decorating. I can't wait to see what you come up with when you try this project. No sprinkles left behind! All right, perfect.
Crazy Aunt Lindsey, how will we make the constellations when the sprinkles are already on?
I'm so glad you asked. I hand drew a couple of helpers to help us remember our special constellations. My constellation is Gemini. Some people think that Gemini makes me extra good at communicating, but I'm just gonna say I love the way the stars cluster together. Mari, what's your sign?
My sign's a Libra.
I love it. Gabe, what's your constellation?
Mine's an Aries.
I love it. You two can start with whatever you like. Which one do you want to be your main star? This activity is an adorable way to personalize your tablescapes for you and your guests of honor.
Let's see.
It also helps us to remember the constellations and their placements by doubling as a matching game that we'll play during our slumber party. Amazing, Gabe. Oh, snap. Here, wash your hands. Rinse them really good to get the blue off.
No. Better.
Nice. I love Constellation cupcakes. Okay, so we have the spinning of the star. It makes it flatten a little bit, but doesn't it expand again?
Well, I can also tell you a little bit about what's going on inside the stars. So stars, what makes them bright and shine with their light is that there are elements and atoms fusing together into bigger molecules, and that gives off energy. So stars are actually a balancing game of that fusion energy pressing outward and gravity pulling all that material in.
That almost makes me think of popcorn. Let me explain. Not only does the shape of a popcorn kernel kind of remind me of an oblate spheroid, but did you know that inside of each one are teeny tiny droplets of water and a soft substance called starch? When the water and starch heat up, gas is released, creating pressure from inside the shell, making it expand and swell and pop. Can you see it? Okay, back to Alex.
And so there are stars that actually do both of those things at different times. So they'll be fusing lots of things, having more energy pressing out, so the outside of the star goes out, and then that energy gets released and gravity pulls it back in. Here, let me show you. So this is called a Hoberman sphere.
Hoberman sphere.
I thought they're a perfect way to talk about this special kind of star called Cepheid variable.
Oh, Cepheid what? A Cepheid variable is a star we can see brighten and dim and brighten again over time. One tool that we use to observe those luminaries is called NASA's Hubble Space Telescope. And it's named after the man that discovered there are other galaxies outside of the Milky Way. Hubble's discoveries are super dope, but they wouldn't have been made possible without one fabulous astronomer, Henrietta Swan Leavitt, the woman that's credited with measuring the universe. She made lots of observations and calculations, ultimately identifying over 2,400 new Cepheid variables. She also realized that the largest Cepheids have the longest time of luminosity, meaning the bigger the star, the brighter it glows. She died a few years before the good homie Hubble announced his discoveries that he made using Leavitt's laws, including the first observational evidence for the Big Bang. Her calculations are still used to this day in modern cosmology, the study of the beginning of the universe. Our running bet is on the Big Bang, the theory that one atom exploded and created everything, which supports my hypothesis that we're all made of the same stuff, stardust. Learn more about her and many other unsung scientific heroes at thefablab.com.
So Henrietta Leavitt was observing this particular kind of star and how they change over time. They get brighter and dimmer in a cycle. And that's because the outside of the star is physically pulsing outwards with more of that fusion energy, and then that energy escapes, and then the surface of the star falls back in. Everything heats up, more energy, starts pushing it back out, and so the whole star is pulsing in and out.
That's amazing. That almost makes me think of like our lungs when we breathe
exactly
in and out.
Yeah.
It expands and then it contracts, expands and it contracts. So it's almost like the universe is breathing through the stars.
And what Henrietta Leavitt did was she observed how these stars pulsed in and out. And by looking at their light curves over time, she could tell how big these stars were, how bright they were, and most importantly, how far away they are. So she helped us discover how big the universe really is.
Very, very, very cool. Thank you. I love this. All this talk about pulsing still makes me think about popcorn. That's why this next cosmic treat is truly inspired. Intergalactic popcorn. All you need for this one is some solidly hot popcorn. Make sure the butter or oil or whatever it is still a little sizzly. We're going to use some Parmesan cheese and sprinkle that on. While Gabe does that, we're gonna do a little bit of chili powder. Then I'm going to add some garlic salt, onion powder, edible glitter salt. That's good. Nice. I think our interstellar popcorn is all ready.
So we've talked about how stars are shaped, what's
Shapes.
going on inside. Some
Inside.
of them physically change.
Cepheid variables.
Cepheid variables. But eventually, stars are going to run out of fuel. And when that happens, stuff gets interesting. I have a bouncy ball for each of us.
Love this.
And a ping pong ball for each of us.
Cute.
What we're going to do is we are going to explore a supernova.
A supernova is what it's called when a star dies or explodes, and they can glow brighter than the sun.
So stars are a balance of fusion pressing outward and gravity pulling inwards. And when that fusion runs out, when they run out of fuel, there's no more outward pressure, so gravity wins. It pulls all the stuff in, and eventually there's no more space. The stuff from the outside bounces off and flies back into space, creating these beautiful supernova remnants. So we're gonna mimic that with these two bouncy balls.
Cool.
So let's take just the first one and hold it out at arm's length, and we're gonna bounce it.
Okay.
So it bounces to about our waist. Let's try the same thing with the ping pong ball by itself.
Okay.
Even less. But now what we're gonna do is we're gonna bounce them together.
Okay.
So we're gonna line up the ping pong ball on top of the racquetball. And we're gonna
Okay.
try and drop them at the same time.
Okay.
I know, we've gotta be coordinated. Ready? No, wait. Okay, we're gonna try again. 3. There we go, we both got it. Nice. So what's happening is the ping pong ball is bouncing off of the racquetball when it falls, and all the energy from that throws the ping pong ball out way farther
All
than it
over
can
the
go
place.
by itself.
Very cool.
Just like the outer layers that hit the inside part of a supernova. It just blows the whole thing apart, way bigger than it would on its own.
That is so cool.
Isn't it amazing?
Yes. Alex, we just learned so much, but I have another question for you. Have you ever had a galaxy smoothie?
Not yet, but now I want one.
You're about to. There's the science. Now let's make it fabulous. Next, galaxy smoothies. A galaxy is a huge collection of dust, gas, billions of stars in their solar systems, all held together by gravity. This happens in 3 layers, and it celebrates all the things that are happening in the sky that we can't see with our naked eye. Our first layer is the what?
Milky Way.
The Milky Way layer. Feel free to use your favorite allergy-free or nut milk alternative for any ingredient in this Fab Lab recipe. Now pour and swirl like the spiral the Milky Way galaxy swirls in the sky. Next, we're gonna put our supernova layer, and now it's time for what?
Berries.
Oh yes. For this layer, we're adding frozen raspberries to cool things off, and a scoop of nut butter to more yogurt. That's okay. Now pour your supernova on top of your Milky Way. Now it's time for our black hole layer. I love it. Okay, so what do you think we need for this one, guys? What do you know?
It's too late to save Mari.
To mimic the superpower of a real black hole, we're adding frozen blueberries and some activated charcoal dust to the 3rd layer of our galaxy smoothie.
Oh my goodness. Cheers to the delicious smoothies.
Good job, guys. Sounds like our slumber party guest Emory has arrived. Now it's time for the Fab Lab Active Hour. Take it away, Holly.
Hello, beautiful humans. My name is Holly, and I am the education director for the Fab Lab. The first thing we're gonna do is we're gonna put the sun to bed. So to do that, we're gonna take a deep breath in from here and raise our hands up over our heads and capture the sun. And when we exhale, we're gonna lower it to the ground. And then when we inhale, we're gonna bring the moon up into the sky. Are y'all ready? Okay, deep breath in. Grab the sun, exhale. Let's put it to sleep. Inhale. Raise the moon up into the sky. Let's link our hands together. Inhale, flip, and put our palms up to the sky. Beautiful, beautiful placement of moons. Exhale, hands back down by our sides. Good job. We are now gonna become some constellations. What are some of the constellations that you...
A Libra.
A Libra.
Aries.
Aries, beautiful, yes.
Ryan.
Orion, and I'm so glad that you brought him up. Because the first two constellations that we're going to do, that we're going to become, are Canis Major and Canis Minor. They're Orion's hunting dogs, and they follow him through the sky every night. So let's go ahead and get in plank position. Do you know how to get in plank position? Okay, go down to the ground. That's right. We're going to drop our belly buttons as we inhale. Lift your chin to the sky. Okay. Exhale, and we're going to flip our bodies up and go into downward dog. Good job. Inhale, upward dog. Exhale, downward dog. Okay. The next constellations we're going to become are Leo and Taurus. We're going to do cat and cow. Inhale, cow. Exhale, lion. All right, y'all did great. Are y'all ready for bed? Do you feel better? Do you feel like some of your energy has
I just
been...
want to sleep.
That is exactly what you're supposed to want to do.
Go back to your position that you were in.
This episode's Kid Book Club pick is one of my all-time favorites, A Wrinkle in Time, a science fiction story by Madeleine L'Engle that follows Meg Murray as she finds her way back to her dad, a man who spent his entire life lost in his work, and now somewhere in space, time, and another planet. It's sci-fi, it's fantasy, and it's super scientific, and stars one of my favorites, the magical power of love. In the meantime, check out the Fab Lab library shelf /astronomy for the full list of Fab Lab astronomy favorites that you can check out on your own. Here you go, my man.
Yay!
Nice. Oh, you're gonna give it a try? So brave! I'm really into it. Where's your glass?
Yay! To this delicious place.
Oh, which one is this one?
September. Gemini twin. The twins. I believe that's yours.
Gabe, you just made me feel so special.
My tongue is probably multiple different colors right now, but I do not care.
I'm one of a kind.
This party's so fabulous that I have to say thank you to everyone that helped make this episode possible. First and foremost, the sun. Thanks to Henrietta and Hubble for their work so we could better know and see the universe. Thank you also to the Fab Lab community of creatives, parents, and patrons at Patreon and iFund Women. Without you, we would not be here. And of course, I need to say thank you to my favorite little Fab Lab professors. Emory, Gabe, Mari, you, and me. Because science is fabulous. Thanks for watching. Thank you to OMSI, the Marie Lamfrom Foundation, and the entire Fab Lab community of patrons on Patreon and iFund Women for making this entire season of STEM programming possible.